My idea had been, on request of Friedhelm and others, that we should float a sample problem that we could agree on, that we can then go back to our own respective cultures and, as Friedhelm said, in the attested method of the day, try to solve that problem to see, step by step, to see exactly if possible, the mode of thinking that went into it in those days. Now, because Friedhelm asked me that, and because I'm mostly involved with studying ancient Indian mathematics, I immediately thought of the Bakshali manuscript and the various documents that we have. So that one problem or several problems from that will be represented, that Mayank will screen later. And then I thought it's a little unfair because our Chinese friend, Mayank has read the paper. I don't know, maybe I sent some of you as well, but he has a sample problem to show that the simultaneous solution of linear equations, in which he says 0 is simply understood as a number. And so I thought it would be more fair if that sample problem was also there, and leave the selection up to you, which you think would be better. The advantage for the Chinese sample is that it's probably much earlier. If they solve simultaneous linear equations in the 3rd or 4th century, maybe even, I'm not sure exactly, BC or CE, it would still be contemporaneous with or earlier than probably the Bakshali manuscript. So then it's up to us, since we're solving the problem or trying to solve the problem of when was 0 invented as a number, when did it take on the guise of a number? Supposedly it went smoothly from placeholder to number. Then we should, look at all of the evidence and then decide which is most convincing. Do you agree with that we should look at those two problems, unless Jim wants to add another problem?
No, but the problem from the Mesopotamian point of view, which is that we don't have calculational techniques. We have tables. But I tried to explain this earlier, that unless the problem is one that I know existed as such in the text, I can't really. I could probably make up an algorithm for it, but the algorithm wouldn't show you the calculational problems involved with 0 as a placeholder.
No, but Jim, it would be very, very convincing if you had a word problem that resembled one of the two other problems, the Chinese or the Indian, and they got an answer, whatever way they did, that early or that much earlier. It would be pretty convincing to me that they knew how to solve it.
No, there's no doubt they knew. I don't know what the problem. I don't know what the problem particularly is, but certainly they knew how to solve problems. The issue for me is one of the 0.
Yeah,
that is to solve the problem with the zeros present. I think it's significant. It suggestive that this kind of situation is normally avoided in Mesopotamian mathematics. You don't have problems in which you have to manipulate 0 containing numbers.
And why do you think that is?
I think because the material is for schools, because it wasn't felt to be necessary for teaching the techniques that they were interested in teaching. Why complicate more than necessary the material you're giving, if in the end what you want to do is to simply teach the method?
But is it your sense that they might have known how to do that, even though they didn't? That we have no
Sure.
evidence.
Sure. I mean,
You think so?
I simply have no idea.
I'm sorry.
And this is the point. I mean, I can show you problems that they solved, of course. We have hundreds of them. But I can't show you how the calculations were made, because I don't know that they made the calculations rather than using tables. Tables.
True. First, let's welcome Avinash.
Oh, hi.
Hi, Avinash.
Hello.
We're just trying to set the agenda and trying to select the problem. Could you tilt your camera down a little bit?
Okay. Down a little bit.
Yeah.
Is that
a little
better?
Bit more. A little bit more.
Little bit. Oh, okay.
Kevin?
Oops.
Now something is in the way.
Yeah. I'm trying to figure out what it is.
Okay,
Oh,
you go ahead.
I know. Yeah.
Kevin will straighten this out. Jim, back to this thing. Are there similar problems, word problems, that look like solving simultaneous linear equations without zero? I mean, they're avoiding zero, you're saying, but that indicate that they may understand in principle how to do it.
For that particular question of simultaneous linear equations, I can't think of one right offhand. I couldn't guarantee there isn't. But I mean, I feel a little bit uncomfortable in talking in this sort of way. I mean, we're talking about problems of anachronism, and the idea of this classification by contemporary 18th century ideas of algebra and geometry and so forth. We have a tendency to avoid this kind of anachronism in contemporary history of mathematics, precisely by not trying to impose our categories on it. So that, whereas in the very early literature, of course, you'll read, this was a quadratic equation, these are linear equations, and so forth and so on. You won't find that kind of talk anymore among historians of ancient mathematics, of those I frequent, because these are not considered to be adequate categories for talking about in mathematics of the period. So, I mean, yes, I could convert something into, take a look and see. Simultaneous linear equations don't ring a bell. Simultaneous quadratic equations, yes.
Oh, okay.
But linear equations, I can't think of right offhand like that.
Okay, quadratic will do. But okay, your point is well taken. Okay, we should avoid anachronism, but then the question is, by what standard are we going to analyze this to see whether we can get any further than we are? The point is that to my knowledge, it's a subject which has not really been discussed in depth. That's what frustrated me, is when I started reading about it, trying to find out. Everybody's raving about the invention of zero, but when you ask them, what constitutes the zero as compared to the placeholder, people, I mean, it's just, you don't even get a chance to ask them. It's one author expressing his opinion and speculating, and that's it. So that issue has not really been dealt with in depth, and so we're trying to, it's like uncharted territory. Is it something that we want to do at all? I think we should agree. Obviously, you're here because you think it's worthwhile, and the question is, see how much farther we can get than we have been. So let me now then sidestep this a second and introduce Avinash. Avinash, have you met any of these gentlemen?
Just Mayank, I guess.
Yes.
Yeah. Okay.
speaker.
Yeah.
Well, maybe you can just briefly introduce yourself to the other gentleman and they to you, and then we're all ready to go.
Hello, this is Avinash Sate. I'm retired from University of Kentucky since 2020. And what happened to my screen? Oh, it's blanked.
We
Okay.
can see you. We
Yeah.
can see you.
Oh, okay. Oh, now I can see you too.
Yeah.
All right. So I have been doing mathematics most of my life, except after 2020. After 2000, I started teaching courses in history of mathematics, and that's when I got into the the history as such. Before that, I was only doing Sanskrit as far as the discipline is concerned, but that was mostly philosophy, not mathematics. So, well, that's the story.
Okay.
Should I say something more?
No. That's very good, and to me knew that I didn't know that Sanskrit was your specialism.
Mhm.
It's very useful also because others have been asking for that. If we're going to go back to source material, then Sanskrit is of course crucial.
Yeah.
The other gentlemen, they are proficient in respectively ancient Egyptian, ancient Mesopotamian, and Jeff in medieval Arabic mathematics.
Mhm.
So see, that way we've accomplished something that I've not seen before. To have at the source level people who can speak authoritatively. So we know now who Avinash is. Jim, would you do the honors briefly about yourself?
Okay, I'm also retired. I taught at the University of Paris, mathematics and the history of science. My main interest and my main research work, is in the history of Mesopotamian mathematics, but I've also worked in ancient Egyptian mathematics. I was trained as a physicist, a theoretical physicist, but I've been teaching mathematics and doing history of mathematics most of my professional life.
Thank you. Friedhelm?
Yeah, hello. I'm Friedhelm Hoffmann. I'm Egyptologist at Munich University. I'm interested in Egyptian literary texts and paraliterary texts, including scientific texts.
Thank you. Jeff?
Yeah, I'm Jeff Oakes from University of Indianapolis, just north of Kentucky.
Oh.
And, I'm trained as a mathematician. I'm a mathematics professor at my university, and I began studying history of mathematics in earnest 23 years ago, and that's been my main interest ever since. So mainly medieval Arabic math.
It looks like that and collecting old radios.
Oh, yeah, there are some old radios in the background. That is true. That's more my wife's thing, but so.
And do they work?
Well, I can make them work. I have to replace capacitors and resistors and do a few things. And
Wow.
it's not as hard as it sounds, but it can be daunting.
Right. Okay. Avinash and Mayank have met each other before, and they know each other probably from the literature. So we're back to what we were discussing. We have two proposed problems, and I think in all fairness, should expand that to, to avoid this anachronism, to be able to, if possible, select a problem that has some sort of overlap between these very diverse periods from Mesopotamia to medieval Arabic.
I have one question about that. I mean, I can easily supply an example from Arabic. There are hundreds of these in many texts. But are you thinking of a problem, say a pseudo-practical problem, such as one postman is trying to catch up with another, how long does it take? Or a problem where we're actually doing something like how to multiply 1024 by 416, which is a very different kind of problem, say in Arabic notation.
Well, the point is rather the other thing we have to agree on is what we're trying to get at.
Yeah.
Is there a distinction between the placeholder and the number zeros?
Yes. Okay. In that
Yeah.
case, it should be an arithmetic question from a book on calculation with Indian numerals. But the problem there is that unless the author talks about how they're understanding the digits, it's really impossible to tell through just the calculations whether they consider the zero to be a number or not. Because in the Arabic texts, they routinely operated on zero and yet explicitly stated that zero is not a number, that it's merely a sign where the number would be. So you almost certainly you won't get anywhere just by looking at the calculations. You can't tell if it was regarded to be a number.
Yeah. Avinash has a pronounced opinion about that. Avinash, which is, I think, concurs with what we're trying to get at, the difference between semantics and syntax.
Yeah.
Avinash?
Yeah.
As you told me. Please.
Let's see about.
I'm
not sure what you are referring to.
Yeah, why the Arabs would routinely
that one. Well, my theory about that is it was caused by Euclid. I mean, Euclid's mathematics was known to the Arabics as a little before even than the Indian. And they were trained to think of 0 and 1 as non-existent entities. I mean, in his writing, he would not allow 0 to be said. It was 0, one understood that something got cancelled and so on, but 0 was not to be, not in his list of numbers. And 1 was in a list of numbers, but it was a special entity. I mean, when he was talking about numbers, they were after 1 or 1. And in the case of 1, they had a special status. I mean, all the sentences appear to say, well, this is a special case of anything. I mean, I don't think he would have been able to declare that 1 is the GCD. He stated that GCD comes out after his algorithm, but then whatever you have if it is 1, he would have a different name for it.
Avinash?
Yeah.
You're a historian of mathematics. You must have read as close to the original text as possible. I believe the first rendition of that doesn't happen until about the 9th century. That something is from Euclid is attributed. Have you read? You must have read the Euclidean documents.
Some of them. I mean, I don't claim to be an expert on Euclid.
What I'm saying is, what you're telling us about Euclid, is that from your first-hand experience of reading Euclid, or is that what other people have said about it?
No. It's first-hand in the sense I don't read Greek as such, but I have been looking side by side Greek and English translation.
Okay.
And so these are online documents for the Greek for the Greeks. And
So, Jeff, does that answer your question? That why the Arabs would have denied 0 to be a number?
No, it doesn't, because there were two competing concepts of number in medieval Arabic. One of them would be, say, Euclidean number theory, which existed in completely separately from practical arithmetic. And practical arithmetic freely admitted fractions and irrational roots, which were completely forbidden by Euclid. So the tradition I'm talking about is the practical tradition, which is not informed by Euclid at all. And they did, of course, work with a 0 when they did calculations with Indian numerals, and yet they're considered to be to not be a number. But 1 was regarded universally as being a number in this practical tradition. So, but unfortunately, most secondary texts or tertiary texts that describe Arabic arithmetic do not mention this difference between the Euclidean tradition and the practical tradition. Most people gloss over it, which is unfortunate, and partly what's caused some confusion.
Friedhelm, any comments?
Sorry.
Friedhelm?
Sorry.
Any comments on this issue? We don't want to be talking by ourselves.
I found it really interesting that theory and practice are two different things as regard to numbers or amounts, or however one should call it. In Egypt, we do not have any theoretical text on what is a number. We have only the practical side.
Yeah.
And we don't have numbers. And we don't have zero as a number.
Right.
Yeah.
And Jim, you told us they avoided. So was it mentioned in text at all?
No, we don't. Like the Egyptians, we don't have theoretical texts. We don't have meta-texts on the practice. But just simply putting it out there, my problem would be the difference between what one says about numbers, etc., even in a practical tradition, and what is actually done, how you use numbers. And this is where I'm fascinated by what Jeff tells us about this distinction, but also wary about saying, therefore, in practice, you did not treat zero as a number, because, I'm thinking of the Greeks and going back to what Avinas was saying about the Euclidean tradition, whereas where one is treated as a special case, it's the unity and so forth. Yet, when you talk about perfect numbers, of course, you add one in with the other devices of numbers and so forth. So, even there, you have a distinction between what you say you ought to do and what you actually do. And I think this is an interesting problem that arises, I think, in any mathematical culture about a distinction about the sort of theorizing or philosophizing about what is the basis of what one is doing, and then the actual practice, different usages of what of numbers and how they actually come into play.
Yeah, there is one minor difference between the Euclidean case and the Arabic case. In the Euclidean case, Euclid was kind of contradicting himself when he would treat one as a number. In the Arabic case, I've explained in my article how it is that they could operate on nothing in a consistent way. They could operate on it, and yet they still did not regard it as being a number. There was no contradiction involved there. And then that's because of their underlying concept of what constitutes a number. A number for them consisted of, and this is true also in ancient Greek and in medieval and early modern Europe as well. A number consisted of a quantity species pair. A number was always a number of something. So 5 horses is a number. The 5 is the amount, and the horses is the substance, is what the number's made from. So in this sense, if I have a purse with 5 dirhams in it, 5 silver dirhams, that's an example of the number 5. And if I take away those 5 dirhams, I have nothing. And so they were operating on zero, considering it to be nothing. You can add nothing to a purse and not change the amount, and that was perfectly understandable. So it was perfectly understandable for them to operate on nothing, which was shown in notation as a zero.
And how did the Arabs call it if you have, let's say, 5 horses and you take the horses away and you have only the 5 left?
Oh, no, they didn't. You can't take them.
Okay.
They belong to the horses.
The horses is the number seen from the perspective of quantity.
Okay. The only one we haven't heard yet on this issue is Mayank.
Yes, no, I'm sort of listening rather than talking. My only contention is the same one, that I think there are 4 stages of mathematics in the world. The first is the pure simple arithmetic of trading. Then there is a complex trading which gives you these linear equations and so on, and then geometry on the side. And algebra in the initial stages, it is treated as a language. And the zero really comes into being when you treat it as a language. And in Indians who were specialists in treating it as a language, they never applied it to real world. And I personally think that everything that I've heard so far is consistent, saying as long as you are worried about 1 horse and 2 horses, etc., everything is fine. The idea is, who worried about the fact that 0 horses and 0 cows means the same thing? That is when the problem shifts from mathematics or arithmetic to philosophy. And I think that is a worry that not many people got indulged. It's essentially a freewheeling Saturday afternoon lazing thought that, look, how come 0 oranges and zero cows mean the same? It is not a luxury that many cultures sort of ventured into. That is my personal feeling.
Thank you.
I have one
Yeah,
question.
Avinash?
How did they handle the debt, owing somebody money or owing somebody things?
Oh yes, well that's still what we consider to be a positive amount. It's just an amount you owe.
I know, but
no, they never.
So the statement that I don't owe anything and nobody owes me anything.
Yeah.
Does that make sense in Arabic?
Well, it does.
Mathematics.
But,
yeah.
Well, okay. Yes, it does make sense, but they did not. They did not declare there to be a number associated with that number.
Oh yeah, that I understand.
Yeah.
But,
so they could calculate. They had effectively the same rules for operating on positive and negative numbers and zero that we have. They just didn't conceive of them as negative numbers.
I see. They were numbers with.
Avinash, there's a huge distinction that was new to me also, that you can have the concept of a negative number. I think Jim would agree, and the others, that it's also fairly modern probably to have in the abstract realm something like a negative number, rather than as they used to do, it seems, in medieval Arabic and probably perhaps in India as well and elsewhere. They would subtract a positive number. They only knew positive number. I mean, they didn't even think about numbers being positive. They just had something tangible, and either it was there or you owed it, and you would subtract that positive concept. Mayank, yes, you have to unmute yourself. Unmute yourself.
So there's an old joke about being taught English, and somebody stands here and says, the teacher says, how do you say come here? And that fellow says come here. And then how do you say go there? And that fellow would go there and say come here. I think in the question of losses and gains, they did the same thing. Rather than talk about explicitly losses that I owe something, it was so and so has to get so much from this. And the linguistic use was different. That is my personal feeling. So they didn't get into this idea of negatives in terms of pure who owes who what. And therefore that negativity of that number is an idea that strikes much, much later.
But Mayank, when Brahmagupta defines the operations on zero and he mentions negative, does he mean a negative number in the abstract sense that we do today, or does he mean that positive quantity is being subtracted? That actually is something that's not directly.
No, I mean his names for positive and negative are dhana and runa. So
exactly,
which corresponds to property, which corresponds to money.
In Arabic, they have the same thing. In algebra, they have the same thing, because I'll say these in modern, the way we say them in modern terms, but so it'll be close enough. But when we say x squared minus 10x, there are two components to this algebraic number, which ultimately represent a positive number. To operate on this polynomial, you have to operate on the individual terms. So As-Samawal in particular stated the rules for operating on positives, negatives, and zeros, but he's only talking about the quantities of individual terms that make up one of these algebraic numbers. So he'll tell you a negative times a negative he has words that we could translate as negative and positive, and they make perfect sense as negative and positive, but ultimately all numbers for him are positive, and these are only terms within algebraic expressions that are positive numbers. So it's tricky.
Yeah, I have this one question. It has been in my mind for a long time. So the Arabic treatment of quadratic equations, they would make 6 different patterns.
Yes, they had to.
And just to avoid the negative.
And the zero. And avoiding negative and zero. Yes, because the rules for solving equations use the coefficients. So you cannot have a zero or negative coefficient. So they had 6 kinds of quadratic equation.
Yeah, so does that mean they didn't understand the negative, or did they
They
want to bring it
They
in?
had no concept of negative numbers. They understood that. They understood many of the practical situations where we would apply negative numbers. They just did not incorporate these ideas into their concept of number.
So would it be fair then to between us, I think, not to have a price put on our head and have people come after us to take away anything from anybody, but would it be fair to say that all this credence that's given to Brahmagupta 628 as having defined zero as a number, this, that, the other thing, if he wasn't thinking in terms of positive and negative, but simply as it appears positive quantities that were being subtracted, would it be fair to say that that is not the benchmark? Because Kevin, are you there? Kevin, are you asleep? I was going to ask him to show the PDF of the Chinese issue. That's why I selected it. See? Thank you, Kevin. Is that full screen?
But it's too small.
I can zoom it in. I'm zooming it in myself.
Yeah. If you make your screen
yeah.
full screen, you see what he's saying there is that there's this Fang Cheng method. Oh no, this is not the Fang Cheng method. Oh, here. This is what
The simultaneous equations.
Kevin, can you scroll it down? Yeah. Okay, no, sorry. Yeah, this is not the right one. You can take it away, please. Take it away for now. Sorry, what I meant to say is that he has another problem, which I should also give you, and I may have given to some of you. It's called the Fang Cheng method. And there they do the very same thing that Brahmagupta does about how to treat positive and negative numbers, say from our lingo, in his whatever interpretation they had. What do you do when you add, subtract, multiply, divide, and all of that? What happens to these signs? And that happens very much earlier than Brahmagupta. So I'm confused whether this is, well, I hate to say it, but sort of like the propaganda that has surrounded this issue of looking at Brahmagupta as the benchmark and not at if the Fang Cheng method was earlier and they did the very same thing. Why would we make that distinction?
Well, it's very deceptive, though. It's very, very natural and easy to read Brahmagupta as being modern algebra and arithmetic. It's very easy to do. And I just think that people hadn't read the text really carefully. Honestly, I don't know what Brahmagupta was thinking because I'm not a Sanskrit person. But all I can say is that from my experience with Arabic algebra, someone should go back and read those texts very carefully to try to understand how it is Brahmagupta was conceiving of numbers and what he meant by these, with the examples from Arabic in mind. So that's all I had to say. I did notice when I was reading Colebrook's 1817 translation, which may not be the most reliable.
No, it's pretty good, actually.
I guess he did a pretty good job, but it does seem to me that he is actually doing more than I see in medieval Arabic with negative quantities, but I still don't understand how he understood these quantities. I know that in Europe in the 16th century, they were working with negative quantities and even complex numbers, but but only in a formal sense. They would not consider them to be numbers. They called them fictitious numbers, for instance, negative.
Yes, exactly.
So mathematicians have this propensity for working with objects that don't have any real philosophical foundation. That's just what mathematicians like to do, and I've seen this in every culture I've studied. So the question as to what Brahmagupta was actually doing is really an open one. I don't think anybody's really investigated it in the last, in recent times.
Is it true, Avinash, that that the original manuscript from Brahmagupta Siddhanta, so no, that's not the one.
Brahmas Sputa Siddhanta.
Was that the 628 text? Is it true that
Yeah, I mean, it's different from the Khanda Khadyaka, which came later
yeah,
in his life.
right? But the 628 document, is it true that the original is not extant? That it has to be translated back from the Sanskrit to the Arabic back to English? Is it available?
I mean, I haven't seen a manuscript as such, but I don't think it was translated from somebody else.
Yeah, there's no Arabic
Yeah.
version.
Yeah,
It exists only in Sanskrit.
yeah. The Arabic version only is for the second book, the Khanda Khadyaka. That was the Karana Grantha, which gave formulas of treating things. I mean, he wanted to simplify the matters. His was too theoretical, and so.
Okay, so maybe it's my misunderstanding. I thought that the Brahmagupta text was lost and had to be retranslated from the Arabic or the Latin or whatever.
No.
Okay, all right. So it is available, and so we can go back to the source and answer Jeff's question, Avinash, if you feel like it. I mean, you're the only one who's capable of doing that, I think. Mayank, you don't read Sanskrit, do you?
No, I mean, not in a manner where I would be confident of myself.
Yeah. So that is something that you could possibly consider to see, but I don't know if you might put your life on the line. Throw yourself in India again after that.
Yeah, I put my life on the line talking about Arabic mathematics.
They were trying to convince you to have the Arabs claim algebra as being Arabic.
Well, of course they do, and I tell a joke. See, there are some people who claim that Diophantus is the father of algebra. Some people claim Brahmagupta is the father of algebra. Some people claim Al-Khwarizmi is the father of algebra. And to that I say, the mother of algebra must have slept around because nobody knows
at different times, though.
Yeah. So based on what I understand, based on the sources I see, no one knows when algebra was first developed. It probably, if I were to guess, developed somewhere in the Middle East, but there's no textual tradition for something that originated orally. Diophantus happened to have written a book in which he solves problems algebraically. So did Brahmagupta, so did Al-Khwarizmi, but these people were all, in my view, lifting from an oral tradition of practical problem solving. So, I would say none of them.
Does that make sense, Mayank, from for your knowledge? Because you make that clear.
It does make sense in the sense that I've had this idea that zero of mathematics was invented by people who are essentially linguists and philosophers. And if you look at Bakshali, that actually has the precursor to what Brahmagupta would do later on. And in that sense, I think it's a continuing same intellectual tradition that comes from Bakshali all the way down to Aryabhatta, Varamira, and all the way to a Kerala school. Yeah. So my whole claim is that we are unnecessarily mixing zero of sciences with zero of language of mathematics to the original arithmetical structure.
Yeah, well,
and that's where a lot of confusion arises.
Yeah, by algebra, I'm not talking about zero in the arithmetic. I'm talking about the technique of naming unknowns and problem solving, which is not necessarily related at all to the Indian numeral system.
No, that I think
That's
I haven't seen, but I'm not an authority. Avinash can comment on that, sir. Whether they took unknown variables and solved it explicitly.
I mean,
well, they did trigonometric functions. So in trigonometric
Brahmagupta does it left and right. He's the big question about the so-called Pell's equation is a two-variable arithmetic problem, purely number theory.
Yeah.
And no, I mean, he even I have gone through this in one of my papers, that he has even analyzed the simultaneous equations in several variables, but he is looking for integer solutions. Right. And that's where he brings in his Kuttaka method, but eliminates one variable at a time.
Right.
And then he goes on. I mean, that's his recipe.
Yeah.
So, we're leaving Mesopotamia and Egypt sort of out of this discussion because there's nothing comparable. Jim?
It really depends on how you I look at the material. I mean, first of all, the idea of what a number is not the same in practice because numbers are abstract in Mesopotamia. Numbers where you have a possibility of a zero appearing as a placeholder, that is, the positional notation comes in when you have an abstract number system, which is totally divorced from the metrological systems in which originally numbers were embedded. So you don't have the situation that you have that Jeff was describing in Islamic countries where this seems to be not what is of interest. In Mesopotamia, you have this base 60 positional system, which is constructed so as to essentially evaporate or at least make transparent or out of the way all references to measure. Within that context that I'm talking about zero as a placeholder and also as an object as something which can be operated with and in conjunction with other numbers, numbers.
Right. Yeah.
So I mean already there's that difference. On the other hand, I'm thinking of what Guy Mazar once said in a conference I organized about we Indians, he being as French as you come. We Babylonians don't.
We the people.
We the people. Sorry, now I've thought.
But it's very interesting because what you're saying is the problem that medieval Arabic mathematicians faced, thousands of years later, harkens back to a period that the Mesopotamians had leapfrogged long before.
But that I think is too linear a position. That is one way of doing mathematics, that you take him in turn, and that at a given point you go from stage A to stage B, and everyone has to do that. And I don't think that's the way it works. I think we have different cultures, very different traditions, and very different ways of dealing with numerate questions and finding the answers to them. And that's what I think makes it so interesting. I'm delighted that it isn't the same in Islamic country as it is in Mesopotamia, and so or in India. So I think it's really quite interesting, which is why I don't have this sort of benchmark idea that there is the point where you hit zero and then once you have it, it's acquired and you've really got it. And I really feel that there's all kinds of ways of dealing with and using numbers of different kinds and treated as different kinds of objects, and that this is something that is something you have to tease out of the material that you have, because very rarely do you speak about it, or even when you speak about it, you don't necessarily have to believe what they're saying about it.
But Jim, to me, maybe that's something I have to deal with, but to me and to others, or some others at least, also our cognitive scientists, he points out that there is a leap from the empirical when you go to that level of abstraction, when you deal with numbers purely as divorced from any species, as seems to have been happening elsewhere. Do you not subscribe to that notion that there is a leap of abstraction, that it does show some sort of state of consciousness that's different from the previous one?
There's a step of abstraction, but what I was trying to indicate is that in talking about what I wrote many years ago about the way in which the sexagesimal system arose, and the way that I've been talking about Europe in that context within this group, both of them come from a kind of material reality, which in essence, essentially, if it doesn't dictate, at least it constrains what kind of solutions you're going to have, and it also illuminates certain kinds of solutions which come naturally out of that way of representing what you're dealing with. So the zeros as blanks comes absolutely naturally out of the fact that the sexagesimal system in Mesopotamia is additive and has a two-part construction. The 60 basis comes naturally out of the choice of a particular metrological system and the reforms and constraints of writing and changes in writing styles that occur shortly before the sexagesimal system is reached. So, I mean, I don't want to say that there is some sort of, leap which is somehow identified with some sort of neurological constraints in our mind that produce this. I think I'm much more culture specific. I think that these things arise in different cultures may or may not arise in different cultures at different times. What is fascinating is that all cultures, or all literate cultures, seem to develop ways of dealing with mathematical questions. This is interesting to me, and to some extent, therefore, universal. But beyond that, I think that they are very culturally determined. I think the kinds of things that I've been hearing here about India and about Islamic countries, and which I either already knew or I certainly have been learning from Friedhelm, is something that is really absolutely fascinating in its variegated nature. And I think that there is that this is a very, very interesting point and a way in which different cultures can be understood. And I think that the distinctions between them as well as the similarities are what are going to lead us to understanding better what it means to invent or discover something in mathematics. And I think that is also a very interesting question.
Right.
Yeah, I agree with everything Jim just said. I have to make one clarification though briefly before people continue, and that is that in Arabic mathematics there is also this abstraction. If you read an arithmetic book in Arabic, they don't talk about the species or the kinds of number. They just work on the digits. And that's because if you want to multiply 12 by 15 and a half, the context is irrelevant. I mean, you might be buying 12 things that cost 12 and a half, 10 dirhams a piece, or you might be measuring the area of a rectangle. So they work eligible abstract units. In the same
this was my question. What happens if you have 5 horses and you leave out the horses? But now you tell us that they also use the numbers themselves.
There always was presumed to be some species. So when they wanted to consider 5, they would shift to 5 abstract units, but the units were still there.
Okay.
Like they would count them interesting. They would count the abstract units in dirhams, the silver coin. Even if the problem was about a number of men or about the area of a field, they would call the units dirhams. So the silver coin became the stand-in for abstract unit, although they sometimes count them in units. There's a word for unit itself, or in number.
Yeah, but Jeff, this sort of begs the question a little bit. If, as Mayank has pointed out, when children learn mathematics, they always still think in terms of apples and pears and oranges. Even though they may be using, the numbers abstractly, seemingly abstractly, in the back of their mind, as he says, they're always thinking in terms of some material substance. And you're saying the same thing, basically, that the Friedhelm's question, do they use the number separately? You said no, but then you came back and said, well, they're still thinking about it in those terms.
Yeah, well, my point is there always still were units. You can't. They didn't work with pure quantity.
This is the point. So the question is, has the empirical divorced from the abstract, or is that a crucial?
For practical purposes, it was divorced, but they still.
For practical purposes, it was divorced. Okay.
Yes.
All right.
I have a few.
Yes.
There are too many questions or comments I have. Sorry.
No, that's why you're here.
So the first one I wanted to raise is one talks about these practical problems as opposed to theoretical problems. So when one says that the Arabic mathematics concentrated on practical problems, how many of them were practical and how many were purely theoretical? I mean,
Well, okay, there was. It's really difficult to classify. You can't classify every problem as being theoretical or practical. There was always some kind of overlap between them. There was an influence later in Arabic arithmetic of Euclid on practical mathematics. There was an influence of practical mathematics on theoretical mathematics. They had words for theoretical and practical. They were aware of the distinction. But so there are some certain problems that people today sometimes call recreational. And when people call a recreational problem would be a problem which is clearly not practical, but maybe posed in practical terms. But in reality, there were no such things as, well, they weren't solved for recreational purposes. These problems were posed in school settings so people can learn how to use numbers that they can later apply in real life. And these problems can appear to be very theoretical. They have nothing to do with practice.
Yeah, but so you are saying there were independent things called numbers that one was trying to teach about.
Yes, absolutely, yes.
So why are you saying they are always connected with some objects?
Because numbers consist of objects. Even in Euclid defined a number to be a multitude composed of units.
Length of a segment.
No. In Euclid, he represented numbers by line segments, but he defined a number to be a multitude composed of units.
Yes.
In book 7, in the beginning of book 7. So the number is the units in Euclid.
But where did he get the root 2 coming in?
He doesn't ever talk about root 2 as a number. He talks about the ratio of the diagonal of a square to its side. That's a ratio of geometric magnitudes.
Right, but that's not a...
This is unrelated to numbers.
No, but he did argue that it doesn't come from dividing one number by another.
That's true.
That big thing he did.
Yes. He's talking about proportions. In book 5, he defines proportional ratios, right? So you can have the ratio of a line to a line being equal to a ratio of a number to a number. So Euclid showed that the ratio of the diagonal of a square to its side is not the same as the ratio of any number to any number.
Yes,
but it still resides entirely in geometry.
But what number did it represent in his definition?
No. A ratio is not a number. Ratios are relations between objects. They're not objects unto themselves.
I know, but the square root 2 was a different number. It didn't fit his pattern.
In Euclid, there is no number square root of 2.
That's right. So why did he talk about it?
He didn't talk about the number square root of 2. He talked about the ratio of the diagonal of a line to its side. That's what he talked about. He's talking about the ratio of one geometric magnitude to another. We can translate it into a number, but he did not. This was completely unrelated to numbers for Euclid.
No, but he talked about the length.
Yes. No. Euclid never talks about length anywhere. He only talks about the ratio of a side to a side.
But square root, the diagonal is not a number by his definition.
No.
Yeah. Okay. Go ahead.
Okay. Mayank has his hand raised.
What I'm saying is that this is somewhat similar to the Pythagorean triplets that Indians come up with, but don't quite solve the x square plus y square equal to z square. They know that if they use right angle triangle, then only in certain conditions you will get a real number. Otherwise, you get a number which is not real.
Yeah,
and they know the Pythagorean triplets. So that's a similar thing.
By real number, you mean what?
No. So they realize that only for Pythagorean triplets, if you take a right angle triangle of these sides, the third one makes sense. And then they don't answer the question about what happens if the sides are different lengths. So in that sense, they do this root 2 being irrational, and just don't get completely confused and leave it at that, saying that no, only these triplets work. it takes Pythagoras eventually to make a generalized rule about a square plus b square.
Before we get further ahead on this, I wanted to ask Friedhelm this question for a long time. What we know about the Egyptians is that they did not have a positional number system, and they did not have zero, and yet they must have been doing most of these things that we've been talking about equally well. Have you been able to disentangle how that might have happened, even though we may not have calculational methods? First of all, did they do all these calculations?
We do have calculational methods for multiplication and division. We know how they did it because a great part of the mathematical papyri we have are the written calculations, how they did it. And this is done by a repeated doubling of numbers. Yeah. For example, if you want to multiply 12 times, let's say, 7, 12 times 7, they write a line 12, 1, 24, 2, 48, 4, and that's it. And then you have 4 on the right side. 4, 2, and 1 together are 7. So you have to add the three numbers, 12, the three amounts, 12, 24, and 48, and you have the result of 12 times 7.
Okay, this is what Avinash was saying, that without zero, they can still do this by simply by adding and subtracting. Yeah,
they can do any multiplication. Yeah. And the division would be the same, only in the opposite way. Looking how often fits a number into another quantity, and they get the result. But we do not have written additions and written subtractions.
No, academia.
I thought that was the basis of their mathematics, the adding and subtracting. So that's what the numbers were. They could add and subtract. What they try to do is convert the multiplication to an addition and subtraction.
Well, yeah.
Sorry, I haven't got it.
Oh, I mean, they had the concept of adding numbers. And then when they ran into multiplication, they found a way of doing it with addition.
Yes.
I mean, that's one big difference I find between the Greek system, I mean, and the older ones, and the Indian method. In Indian method, they never bother to define what the multiplication is. They consider it as an abstract map. From two integers, you can produce another integer by this rule. And they were building the multiplication structures directly. Its interpretation as this digit by digit multiplication, that came a little bit later.
At Friedhelm, I think you ought to explain also that they did more than just doubling and halving. That in the Rhine papyrus or in the Rahun papyri, there are other techniques used in the actual calculational section. Yeah. So, I mean, that I think is important because one of them is multiplying by 10, for example, or dividing by 10.
Yes. And, sometimes they did it. Yeah.
You have to do it because unless you're doing only integers by integers, you don't have a finite algorithm in having it. You do have it for your integers, but of course, the real strength would lay in fractions and manipulating fractions, and doing this. They had very sophisticated techniques, as you well know.
So, did they handle numbers with zeros in them, like 10, as you said? No. I mean, 10 has a zero in it.
No. They have a different sign for 1, for 10, for 100, and so on. So, and to multiply by 10 is very easy. You just use the next
shift.
You just shift the what is it, potence.
Yeah,
Right.
but then what happens if you run into 108?
108?
Yes.
Yeah, you have the sign for 100, and you have 8 times the sign for 1.
Yeah.
That's it. And you do not have to indicate the missing tens.
No, that I understand. For additive systems, you don't need the missing ones. But he was telling about, Jim was saying something about they were using other techniques of calculation. I would like to see an example.
I think Jim referred first to what I had explained was the multiplication by use of doubling the numbers and then finding the fitting sums, and then you have the result.
Yeah.
Another thing is you can skip this, or you can shorten this way by multiplying with 10 directly. This would be very easy. And sometimes, the largest problem where, from a purely technical point, was how to deal with fractions. You see, the Egyptians did not write, let's say, 3/4, but they wrote 1/2 and a quarter. And in their system of multiplication, you have to double, for example, 1/6. And you could not write 1/6 plus 1/6, because you could only have one particular fraction in a series of fractions. So you had to learn by heart that to double 1/6 is 1/3.
Okay,
And
so
there exists also a table, the famous 2 divided by n table, which shows the results for doubling any fraction from 1/3 to 1, I do not know, 19.
101.
Oh, 101, yeah. What is... So, at some point in the history of Egyptian mathematics, one had the idea that instead of doubling 1/49th, one could divide 2 by 49. And this would be the same result. But it's a completely different way to get the results. And we do not know how they did the calculation. We do not know how they... or at least this is not written down in this text. It gives only the result. 2 divided by 49 is 1 so-and-so plus 1 so-and-so, and so on. The results were correct, but...
This is not about the current discussion, but it always was amazing to me about writing this 2 over n and giving a standard table for splitting it into the so-called Egyptian fractions. How to write them as sums of Egyptian fractions. Egyptian means 1 over something. And I was trying to teach it to my students, and in many cases I see a better way of doing it, even smaller numbers. So did they have a philosophy of how they should construct this split?
I've never dealt with this, but I know that mathematicians have recalculated many of these results, and as far as I know, most of them are really convenient, and some let's say types of numbers are treated always in the same way. All numbers which are, for example, to be divided by 3 or some things like this are always doubled in the same way. But there are nasty numbers like 1/17th, 1/47th. This is really nasty,
Yes.
So, gentlemen,
I think
but here again, the result is given in a additional in a way of adding a series of fractions.
Yeah. I agree.
Jim, you were going to say something?
I was going to just something about the 2 over n table. I also calculated it for my students. Yes, I mean, when the point is to know what kind of breakup they actually wanted. I think that this is something that who is his name? Cunning wrote a book about Egyptian mathematics in the 50s, 60s.
Neugebauer? No.
Sorry?
Neugebauer? No.
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 An Australian mathematician. Ridiculous. Okay, a little important. I wanted to say this, not my suggestion, but what he pointed out was that when you choose that the optimal thing was not simply the smallest, but the smallest even numbers, because if you wanted to double again, you wouldn't have to reuse. If you had to split up into 2 even fractions, 1 over 2n plus 1 over 2m, you wouldn't have to, in doubling again, you wouldn't have recourse once more to the 2 over n table. You could do it automatically, directly, very simply. So this was one of the criteria that was clearly at work in this. So there is no, as far as I know, I've looked at most of the publications on it, no known algorithm that covers all cases in the 2 over n table uniquely. There are some that are probably indicative, as Friedhelm says, but certainly what is true is that whatever choice they made, it generally was the smallest and or even divisions. And this is something that is that makes perfect sense. Even the Egyptian, what you wanted to do with it after you did this, and then continuing the calculation.
I see. I never thought of it. That's good to know.
But here again, I think this is a result which was get from the praxis, right?
Gentlemen, I think we've sort of, for now, exhausted this aspect of it. What I wanted to also touch on, and that you may be averse to this, one question I'd meant to ask Jim about the very earliest. I was fascinated by Jim's reproduction of a tablet from the 3rd millennium BCE, in which the first placeholder square clay appears, and that was on an outlying area, Jim said, of Diyala. Was it Diyala?
Sorry, no. The earliest one is from central Mesopotamia. I think you're thinking of the first non-blank sign, the first explicit sign to represent a placeholder, which comes from one comes from the Diyala, one sign, one choice of sign. The A comes from the Diyala region in the north, one choice of sign. The Yam comes from Elam, Susa in the east.
So you're saying the first blank space that appears in the clay tablets is in Central?
Is in Mesopotamia proper, yes.
Third millennium BCE.
Third millennium, yeah.
Okay, because this is my hobby horse to try to connect. See, my original idea for launching this was that the idea that I had about 0 was that it had not appeared in the historical record for tens of thousands of years since tally marks were found 40, 50,000 years ago. Nothing happens. You do get then the place value numeration that comes in, which is a huge breakthrough, of course, when you consolidate your mathematics that way. But then again, it happens without 0, and then you begin to see this placeholder. And so to me, it was sort of inexplicable. Well, why would this have happened? Now, it could have happened naturally out of practice, that it was dictated by the practical needs of the day, or it could have come from some larger philosophical context that may have, say, influenced the intellectual climate that permitted that in the first place. and by conversely, why it would not have happened elsewhere where such a climate was absent. That was my original idea. Could that account for the invention of either the placeholder or the number zero? And so I'm always trying to dig beyond, since mathematics does not evolve in a vacuum. Even in Mesopotamia, there was a huge civilizational context within which this took place. The question is, was there something beyond mathematics that facilitated this invention, and conversely again, that if it was absent, that would have impeded this invention. So I wanted to go a layer deeper, like an archaeologist, sort of dig a layer deeper. Friedhelm?
Yeah, my opinion to this is, in early administrative texts, also in Egypt, it was very fashionable to draw up tables, spreadsheets, and you have let's say, the dates, and you have people, and in the fields you say so many items, and if there is no entry, this means there is no amount given to anybody.
Yeah.
So, and the same system of, let's say, bookkeeping can be used for writing numbers. Can't it, Jim?
Yeah. But I'm not. I mean, the tables play an important role in Mesopotamia because they're used to do the calculation of work, in a sense, and then you are arranged very neatly. So these aren't the administrative texts that you're talking about. There are such administrative texts, but you don't. But there and there you have blanks in them. This is quite true. In fact, I showed some. I think.
And you showed to us that as soon as they do not write these numbers in tables, but as soon as they begin to write them in a continuous, coherent text, they have to indicate, and properly there should be an empty space or an empty,
Yeah. And this is much more difficult to do in these continuous problem texts compared to the tabular tables that are used. And this is why it's in these problem texts, procedure texts, that you first have zero as a placeholder and zero as a placeholder. I mean, you have a blank as a placeholder, and you have and later you have specific signs as placeholders, empty placeholders for this kind of work. So yes.
But you see no connection. You see no connection to the larger, say, philosophical context, either within Egypt or Mesopotamia. Not necessarily, just purely out of practice.
You see, that's the way it seems to me. I mean, I told you about there's no philosophical tradition, but there is a mythological one. And as I told you, Peter, this is water. If there is one sort of basic Mesopotamian cosmogonic idea, is that of water as being a primeval element, and which is then later transformed by the gods into various kinds of matter. But
that's not as trivial as you may think, because water may also symbolize not just water, but the fact that of the idea of monism, that there's one thing, whatever it is, we call it water, but it could be anything. The Greeks had the same transition. So the idea of monism in philosophy, making its entry, is a very important concept.
Except it's dualism. It's dualism because there are two kinds of water. There's fresh water and salt water, and they intermix, but they're never called by the same name, and they have
if you're sensitive to the philosophical mode of thinking, there's a lot of symbolism out there, I've found, that appeal to common people. Not everybody is a thinker, and some people just like the simple way of representing something or thinking about something, or rather not thinking about it, just accepting it. And the idea of water you could see as monism, but then you could say two kinds of water, that also could represent dualism. Out of the monism, which is impregnable. If something is one, there's no distinction, and you can't do anything with it. As soon as it breaks up into two, then you have an infinite number of variety of possibilities. And you have the same thing in other philosophical traditions, where you have, say, one God. You might call it God, or you might call it anything, and then something happens that God creates distinctions, and then you're off and running. Like, for example, take for example the Garden of Eden. You have Adam and Eve, prancing around a paradise, and everything is fine. And then what happens? They make one distinction. They eat from the tree. This is very telling to me. They eat from the tree of knowledge. They eat the apple. Okay, so for common people, okay, well, he shouldn't have eaten the apple. The snake tempted him to eat the apple, and he shouldn't have eaten the apple, and there's the problem. But the apple represents the first distinction that you make in that particular case. What is the good and bad? What is good and evil? As soon as you make the first distinction, all the rest follows. And so you have monism, you have dualism, and then you get the whole pluralism of all those combinations, and you get the confusion that we find throughout history in every culture. And the very issue that every culture and every religion tries to resolve, of trying to find your way back upstream against all of these distinctions, back to this paradise that was paradise lost. If you look at it, say, that way, then water is not as trivial as it may seem, and two kinds of water also is not as trivial as it may seem. That's sort of what I'm looking, because why I'm doing that is that if you look at it more pervasively than that, even if you then look at monism as being, say, the unit, Euclid's unit of composites, of which numbers are made, the multiples are made out of that one unit. If monism is one, and civilizations know nothing but monism and dualism, then you're unlikely. That was my idea. That you'd be unlikely to invent the number zero, because it doesn't represent anything. The concept of nothingness would have to be highly sophisticated and evolved for you to be able to even conceive of zero to be a number. Now, I find that to be very much present in India, because that kind of philosophy was there. I'm trying to find it in China and in Mesopotamia and in Egypt. The Chinese had something very similar to that, except they're also very practical people, so the connection is not clear yet. And our Chinese friend has not been able to find any reference in texts to corroborate that, which is surfeit in India. The question. So why I'm trying to probe now Mesopotamia and Egypt and abuse this privilege. Also, by the way, medieval Arabic. I was very curious to see what their philosophy might have been to be able to accept zero as a number or not. But that is where I wanted to go, if at all possible. And then again, if it can be corroborated in some way, if it can be substantiated by any kind of evidence, textual or otherwise. So, Mayank?
I wanted to make a side comment which is completely irrelevant otherwise, but I think there is something fascinating about it, which is that in all other languages you have singular and plural, and that's all you have. In India, we have singular, then there's a special case of two, and then there are many. So,
and Egypt also.
And also
sorry?
And also Mesopotamia.
So even if, for example, plurals of everything. So
duals, yeah.
Okay.
Yeah,
so they are there in other languages also.
Yeah, Arabic too.
Yes, and I've always
and
wondered
in Old Greek, in Old Greece, for example.
Okay. My mistake.
But then why this aversion to nothingness? Was that there in Egypt?
Sorry, a notion of nothingness.
What was there an aversion to the concept or to this idea of nothingness? Was there aversion to it at all?
Aversion.
Aversion, say rejection of.
Yeah, well,
This is hard to tell.
This horror vacui, this idea that the Greeks had, at least some,
Yeah,
not monolithically, but I mean the mainstream, from Aristotle, Parmenides, nothing cannot be something. Period. End of that discussion. And the fear.
Well, I wouldn't say there was an aversion, because as I wrote in my paper, the Egyptians had a relative converter or relative pronoun in the neuter, that which does something, or that which exists. And they had a negative relative converter, that which not. And the combination of these two words, that which is and that which is not, is a common expression for everything. So those things which do not exist are included in the creation of the world. So I wouldn't say there is an aversion, but on the other hand, there is not the idea of creating the world in the beginning out of nothing. Something exists always.
But is there a negative connotation to that non-existence? As opposed to the idea that you cannot have something without nothing. You see, that's more of a complementary view that seems to be holistic, rather than this dichotomy between good and bad, existing is good, non-existing is bad. That itself could be a driving force or motivation for people.
I think in Egypt it's mainly complementary.
It is complementary.
Yeah.
Okay. Avinash?
I would like to see or hear what those words are, the ones that you are.
Which words?
The words which describe this.
The aversion, you mean, or no?
The Egyptian word.
Words, yeah. I mean, you said their translation.
Yeah.
What are they?
Well, the Egyptian word is netet for that which is, netet, and that which is not is utet.
Oh, I see. Netet and utet. Okay.
Jim, is there anything similar in Mesopotamia?
No, I can't think of. There is. I mean, you can say something exists, and which is the bashum, and does not exist, but then is simply the negation. And I don't see any grouping, such as Friedhelm was talking about in the Egyptian case, any standard grouping of that in Mesopotamian literature.
And no distinct aversion to the one or the other? It's like...
No, because it's used in very concrete situations. It isn't an abstract philosophizing. It's used in terms of...
anyway...
have a right.
So back to the drawing board. Mayank, you wanted to say something for a while?
I just was wondering whether zero or blank went into mythology streams in ancient Greek thinking, and therefore it was not there in the logical thinking. You could not include it. There was the division of mythos and I forget the other word. Whether that is where they sort of forcefully divided the two and therefore never considered abstract in the rational world. I don't know. I mean,
that seems to be what happened. From what I understand, is that there was a sea change from the mythological mindset, probably coming from the Bronze Age, across that whole region, by the way. But this sea change from the mythological mindset to the rational mindset in Greece, which heralds the development of the rest of Europe for 2,000 years to come. That was predicated on this idea that we had to start thinking rationally about
So Logos, I think, is the word, and mythos, mythological and physical. So that probably pushed them away from mixing the two, because blank seemed to be obviously an idea that is not physical.
Yeah, I don't think we'll probably ever be able to know exactly, because it was a huge change in a very short, relatively short period of time that the mindset changed and that rationalism became the mainstream, from the pre-Socratics onwards. So that in itself is interesting, but it seems that it went at the cost of this concept of nothingness. That seems to have been the idea that everything came from nothing was not tenable. So that's why they always, the pre-Socratics started with monism, with the same thing that Jim was saying, everything is water. Or then, that then came the rational tug of war between people saying, no, it's not water, it's fire, or it's not fire, it's air, or whatever. And so they started battling each other. And that process of reasoning it out is what led to, the rest that we know today and still haunts us. You pay a price for everything. And anyway, that's not why we're here. But it does, you get my point that maybe if I'm barking up the wrong tree, we can forget about this altogether. The Zero Project goes up in smoke. There was no transition.
Become zero.
There was no transition between the placeholder. The placeholder came up. It was cited in Mesopotamia, and the Egyptians didn't have it. And then the Chinese somehow came up with their empty column, and the Indians thought of this and that. And they were back to Jim's sort of multiculturalism, where there's like this circus of, or what is it, this potpourri of cultural development across the globe, and there's nothing really we can say about it beyond that. But maybe we should try. And that leads me to my final agenda point, which is that, having heard all of this, do you think that this is the subject matter for a joint paper, or would it be too scattered?
I have one small comment. Hello?
Please.
We were discussing philosophy and nothingness and so on. So in the Indian philosophy of Upanishads, it is quite common to say that this whole world is unreal. Everything you are experiencing is unreal. And in my mind, all it means is something which has a limited time span is unreal. Something which lasts forever is real. And so in the Indian philosophy, nothingness was everywhere. There was nothing to worry about.
Right. So that's why they naturally took to this concept of zero when it came up. But the question is, it seems to have been fairly late. If that had been the case, going back to
the Upanishads go back.
No, zero. I mean, zero coming up as a number came relatively late.
The algebra of zero. Yeah, the algebra of zero takes a long time to come, and that is because I personally think it's a question of social environment. And, a whole lot of ideas have to be cooked. If you suddenly took only mathematics and came out with zero, people would simply use it as a number. It's philosophical profoundness. Last presentation, a speaker said it was an invention that turned out to be a discovery. And I think that's a beautiful way of presenting what happened to zero. It was an original invention that came out to be a discovery. But I think it required a civilization that was not only mature but had enough resources, where philosophers were supported, who could sort of idly think about these things. Until that happened, there was no way we would come to the algebra of zero. And therefore, and Bakshali, frankly speaking, seems to be the starting point rather than Varami or even Aryabhat. Because Aryabhat would have come across these issues when he talked about sine functions and so on. He would have come across sine zero, etc., except that he didn't write down the rules. So maybe somebody else was simply more systematic rather than inventive.
Having heard Mayank, Jim, would you agree that Mesopotamian civilization would not have been in such a state of luxury where they could have, leaned back and thought about these things and did it, or they just simply did not?
The ruling class lived very well in Mesopotamia, as everywhere else. The poor people don't. So, I mean, this is a standard kind of situation in the world, and it continues today. I don't see any kind of lack of leisure time in Mesopotamia for those who were at the top of the social ladder.
And was in that sense a class distinction that it could have been, so it could have happened, right? I mean, if they had that leisure class,
if indeed all men come from the leisure class, yes, it probably you would have to make that argument. I don't happen to believe that. So that puts me in a difficult position.
Yeah, also there has to be a recording of those thoughts and their transmission. You see, there might be other people who would have worried about this idea of what is zero orange equal to zero apples, but their thoughts were never recorded and brought down the generation, because it was at the time when mathematical thoughts were being systematically recorded in India that you get the recording. Bakshali clearly gives you the first indication that there is something interesting about zero which should be looked at.
Of course, you have 3,000 years of writing in Mesopotamia, and so that's not a problem. I mean, access to writing is possible. Of course, it only
but they may not consider it important. So, for example, when Alexander comes to India, he comes with all his great learned men, and he even brings astrology into India. But he doesn't bring this mythos and axiomatic thinking, because he didn't think that was interesting or important enough to be carried across cultures. He instead brought his astrologers and others. So sometimes the civilization may simply miss the subtlety of what is being said. Even Arabs, for example, even though take the zero and use it, the finer subtlety they don't catch until much later. In that sense, is what I'm saying. It is not that people would not have sort of mulled about these things, because they are interesting things to mull about, but it never got recorded and therefore never worked upon by others.
Jim, was there the privileged class who had access to writing, apart from the royalty? Would it have been like a priest class?
No.
The scribes?
No, I mean, there were part of priests, the kinds of priests which were specialized in taking care of the liturgy, but liturgical priests. But no, in general, schooling was something that was indeed limited to a comparatively small portion of the population, mainly male, mainly not only ruling class. That would also be those who served the ruling class as scribes. So this was a certain percentage, very difficult, almost impossible to actually determine now from today about what percentage of the population was actually literate. But people did have access to public writers, so that you could write letters. And we have letters from people who are clearly not themselves necessarily literate, but who had access to public scribes who could write for them. So
were there societies, say like you find in the Greeks, where where Plato or all these people would sort of gather at a house and chew the fat? Was there a tradition of that in Mesopotamia?
I have no idea. Certainly not having left any record of it.
Okay. Friedhelm in Egypt, was there?
Well, it depends on the period. In the 3rd and in the 2nd millennium BC, priests normally were not full-time priests. there were administrative people, and they had to serve in the temple for 1 month. And then they rotated, and the next group had to do.
What did they do when they were out?
They resumed their normal work.
Which is what?
In the administration or wherever.
Okay.
Yeah. In the first millennium BC, there is a certain shift. Writing, which was in former times something done by the administration or administrative personnel, now becomes mainly done by priests. Assmann called it the sacralization of writing. Yeah, it's not the administrative personnel which is the main group which writes, but now it's the priestly group which writes. And the late hieroglyphic and hieratic texts are really very, very artificial, full of theological allusions, and maybe you would call it a kind of philosophy. But we have a problem in our sources with mathematical texts. We have a lot of mathematical texts, many mathematical texts from the early or first half of the second millennium BC. Then we have nothing. And then from about the middle of the first century, middle of the first millennium BC, we have mathematical texts again until the first the first centuries AD. So the first group is completely rooted in the administrative needs, and the later group of texts, demotic texts, then is it's still part of the education of the school, certainly, but the people, we really can't see who were the people who did it, and those who learned to write were attached to a temple. This is clear from the other documentation.
Okay, thank you. So back now to the main thrust. Do you think it's too impractical or too ambitious to try to conceive of or structure a joint article on this? Mayank?
I definitely think it's a good idea, and it would be nice to take some problems and then solve them through different methods and put them in as a question of approach.
Friedhelm? Sorry. More? You wanted to add more? No. Friedhelm, a joint paper?
Perhaps, yeah, but we must think about what we want to write.
Have we selected a common problem, do you think, yet? Has something appealed to you?
Not yet.
Okay.
And from the Egyptian point of view, the Egyptians never solved any complicated equations.
Right.
What they did was something like what we would express as x plus 1/3 x makes 12.
Right.
What is x?
Okay.
That's it.
See, that's important in the sense that we need a standard of reference. So it would be good to have one civilization that managed quite well, and that is what they did. And so if we had a problem that would be conducive to all of our requirements, then you could solve the problem in the Egyptian way to the best of your knowledge, and Jim could Are you on board on this, Jim? Do you think it's a good idea, if nothing else, maybe not to go wander too far afield, but to solve a common problem? I think it would be a contribution to the literature to do that. I don't think it's ever been done before. It's always one author who sort of crams down our throat what they think. And this would be good to have, like, in whatever it is, quintophonics. Jim, do you see any merit in that?
Yeah, sure. I mean, like Friedhelm, I guess. Why not in some kind of way? Though I thought that at the beginning that the point was to not only just take a common problem, but take a common problem which would somehow involve, from our point of view, zeros. Now it seems to be less that kind of thing, and more a general kind of problem, which has to be solved. But I mean, I'm thinking the aha problems to which Friedhelm was referring are problems which were solved not by algebraic techniques, but by false position. And in the Babylonian case, we have other kinds of algorithms coming into play. It's not clear to me what kind of problem would really illustrate these differences and ways in which they would really illuminate the differences.
Preferably both. We take a problem that everybody can solve, with or without zero, just and step by step, so we can put those, compare and contrast those.
So essentially a trading problem, right? A trade problem is something that every culture would have to solve. Taxation, basically.
Sorry.
Because early arithmetic is simple. I have 5 cows, I give you 3 is something that even a nomad would do. But the idea is...
I didn't catch what kind of problem you were referring to.
Trading.
So the king takes 5% of whatever you have, and this is what you have. So how much do you pay the king? Then there is a comparative price between a goat and a camel or whatever you have it. And therefore one has to sit and write down saying that, okay, I have to give king either 5 goats, or I have to give him a camel, or whatever it is. So these are problems that come when the culture is settled and when there is a king asking for taxes. Till then, even though the problems below that level would be solved even by nomads, because they would trade with each other. And therefore, they may not be as interesting, or the variation may not be much. But once you have this, what I call linear equation solutions, those probably would be more interesting to look at in different cultures. We would simply put matrices and solve it. That would be the method of choice in today, but it would vary with culture to culture. Yeah, sorry.
Let's not jump the gun, because what we're trying to do is avoid these conclusions. We want to see in practice, as legitimately as possible, as can be documented, how this evolved. In fact, we may need not 1 or 2, but maybe even 3 different kinds of problems to be able to illustrate this. But the point is, make no assumptions.
Yes.
Make absolutely no assumptions. For example, I heard you use the word percent. All these kind of things. Be very, very mindful of. Try to really put yourself in the position of that particular time warp, and just go step by step. We want to see where the disjunction takes place. Where the problems arise and how these may have been solved. And maybe it takes 2 or 3 or 4 problems of different gradations to be able to bring this out. And then maybe we can go slowly from the simple calculational problems to the more complex algebraic to see where zero may or may not come in. Avinash?
Yeah, I mean, are we trying to look for problems which were already discussed somewhere, or we are making new ones?
Well, preferably if they are extant, in the sense that you can, like, for example, the Chinese example. If we were to take that as a benchmark, and peg it at I think it's the 3rd century. Keep getting confused because they have so many dates, but it's either third century BC or 3rd century CE. I think it may even have been BCE, 3rd century. What is it? The 9 chapters. When is the 9 chapters? Is that BC?
Yeah, I think
No, that's about 1st century CE.
CE.
CE. Okay. So if the Chinese example is there and you can find anything comparable to that in India or in Egypt or in Mesopotamia, it would be extremely helpful, and in India, of course. So that is a very concrete example. If you can think of another example that you would like to present, for example, if you think that this may illustrate your case more effectively than a problem that you may not be aware of, then we could include that as well, as long as we all agree on it, and as long as it's solved, and as long as it'll take time and effort to write it down and to make a unit, to unify it in some way for a coherent article. Friedhelm?
I would suggest, Peter, that you compile a list or a group of mathematical problems, similar to what Mayank said. Imagine the king would come to you and ask for perhaps 5% or another expression of all your income. How would an Egyptian scribe have calculated this?
Okay.
To have a common starting point, this would be my suggestion.
But my problem is that that I am not fully aware of what was prevalent in your particular civilization.
Yeah, but we cannot write a handbook which comprises any common types of mathematical problems dealt with.
The time span is too wide, probably also.
Yeah, certainly.
But maybe we could start there, that you each, since we've had this session, rather than putting the onus on me and having to produce this, if you each float, 1 or 2 or 3 examples that you can think of that ring a bell with, for your particular situation, and then let's circulate those, and maybe make a selection from that rather than me, compiling this. Jeff, you're in a difficult position, being in a much later time warp.
Well, there's a problem from my end, and that is that any of these problems posed in a practical setting would never talk about the actual calculations of the numbers. They would just give the results of the numbers, and most likely they would not have been calculated with Indian numerals. They would have calculated through finger reckoning or some other means. So if you want to get at the zero, you have to look at arithmetic texts where we're dealing with numbers of abstract units.
What finger reckoning? What is nothing in finger reckoning?
Well, they don't have. If you wanted to, well, the finger reckoning was mental calculation in which you use your positions of the fingers to store numbers, intermediate results. So when you speak 5007, you don't say the tens and the hundreds because they're just not there. So you want to multiply 5007 by 22. You just have to multiply the 5,000 by the 20 and by the 2, and the 7 by the 20 and the 2. There's you don't even need to consider.
How do you do that? How do you do that with your fingers?
Oh no! Well, you'd multiply the 7 by 22, and then there are ways of storing the numbers 1 through 9,999 by positioning your fingers in particular ways. I don't have them memorized. So you would put.
Can you give us an example?
Well, I don't remember the rules. Like they would use the thumb and the index finger to store the tens. So bending in particular ways or crossing them. The next 3 fingers would store the tens, and then these would store the hundreds and these the thousands. So you could put your fingers in a particular way to store temporarily while you're doing the mental calculation any number between any intermediate result, because they did a lot of mental calculation.
Peter, sorry. Yeah, if you look at YouTube, and ask for quick mathematical calculation methods, you get these kind of methods of fingers. I think in India, it's fashionable to call it Vedic mathematics, but the idea is that you take these fingers and bend them, and you even currently get videos to do that to children, to teach children to do quick arithmetic. So one can see them, like he says, take the 10 fingers and then bend them in a specific manner, and you can do additions. It is a cruder form of abacus, basically.
Why wasn't that done just once and compiled in tables? That wasn't done, was it?
Tables. This is an oral method of calculating.
I know.
Yeah,
I know. But the Egyptians and the others had tables. Why?
Well, different people have different ways of calculating. This is just one of several ways of calculating in Arabic civilization.
Okay. And Indians hated writing down. They wrote nothing.
But they had tables.
They had
tables, but that comes in 5th century AD.
No, you memorize them. That was
you memorize them. But that is also 4th, 5th century AD. Early periods, my guess is this finger method that Jeff was describing is the one that worked.
Okay.
So trading that is good enough. And instead of percentage, the king would say he will take away 1/6 of all your crops, and then there would have to be equivalences between various kinds of animals that you have and stuff like that, which essentially is a linear equation today. But that is a kind of problem they would come with. Yeah, sorry.
But I fear from as I get our discussion now that the single cultures are in a way incompatible.
Yeah.
We cannot really solve or we cannot display the different ways. For Egypt, I could do it, but in Mesopotamia, we do not know how they did the actual multiplication. We have the tables, and we know they checked what is 1/5 of something. Yeah, and that's it.
Okay,
we can see the results, or we can see they were able to get a result.
No, but that's important too. If you make the point, I mean, part of the article could be, we do not know how they calculated, but they had tables, and so if you're asking me to solve this calculation, I'll just tell you I go to the table, I do this, that, and the other thing, and that's enough. Then people, instead of us having to hammer this out, somebody could read this and take all of this valuable knowledge on board without having to go through this struggle of doing it simply by this pre-digestion that we're doing for them. Well, anyway, think about it. You don't have to decide now. I will maybe raise this question in the group and see who would like to participate. Do you see any merit in it? We've heard from Friedhelm and Jim and from Jeff and from Mayank. Avinash, can you see any merit in doing a comparison like that between the civilizations?
Yeah, I mean, of course, I see a lot of merit in it, but I am still not sure about what kind of problems or what topics are we going to cover.
Okay. Well,
so
that's
we
the
need
next
a scratch. I mean,
that's the next step. If we agree that it's worth pursuing, then we'll do it in the group.
Yeah.
So, but I just have one point to make. So, for example, I would put this kings taking away 1/6 of your produce, etc., as a levy would be solved differently in the early culture. In Mahabharata period, it would be solved differently. Then, when Aryabhat comes around and claims it is fractional, etc., it would be solved differently. So, within a culture, it is time dependent, as Friedhelm said.
Yeah, but that could be taken on board.
So we could take, the examples at different times also. It would be very.
We could have a timeline. We could have a grid, and the different periods in Egypt and in Mesopotamia and all of that, and then put in those problems in that particular. Also, to be able to make a valid comparison that we're not comparing, absolutely two different time periods.
Correct.
Mm-hmm.
So the second point I want to make is that we should include geometry problems, not just arithmetic problems, because all cultures also had this issue of geometries, and I don't know how to do that.
That's difficult
because Egyptians had pyramids, Indians were interested in the Havans. Egyptians, of course, had their circle and obsession with circle, etc. So somewhere along the line, geometry also would make an interesting.
Yeah, but let's take one step at a time.
Maybe right now we should start with
We'll do the geometry later. We'll do the geometry later.
And it's not related to the zero as such.
It is
Well,
not.
we're building up to it. You mean
No, that's
geometry.
fine. Yeah.
You mean geometry?
It gets related
Yes,
to
yes.
pi. You see, the pi comes out to be the first irrational number which irritates everybody.
Mhm.
So it gets connected to pi, but not to
In
zero.
fact, geometry is an anathema to zero because you cannot
Yes,
have
exactly. It is.
nothing.
It is.
You lose everything.
Yes, exactly.
Why?
I concede that, but I thought just that's another line of.
Yeah. No, we will.
Thank you.
Friedhelm?
Yeah. Why did you say is an anathema?
Geometry is anathema to zero
Why?
because there's no figure that corresponds to zero.
Oh yes,
So-
for the Egyptians, a triangle is a quadrangle with one missing side.
Yes. Yes.
Not
With
zero.
a non-existent side.
So what you're saying is that would be the zero part of it? No, what I meant is there's no
Yes.
figure corresponding to.
Well, there's the
Yeah.
point. Euclid defined a point to be that which has no
That's
part.
zero element.
Exactly. Yeah.
You just can't have negative values in geometry. That wouldn't make any sense.
You can't. Yes.
Yes.
But you see, I've heard the argument advanced that that is why Euclid is basically, at the foundational level, non-empirical. Because if you start saying that something has no dimensions, then you're out of the empirical realm. And so even though Western science boasts being, empirical, the foundation of it. Well, this is the ultimate paradox in the whole of existence. I think each individual has to find out for himself that we really don't know, like Socrates says, anything. We know that we know nothing. And we're trying desperately to connect as much as we can of what we think we know to what we do not know. But ultimately, you know no thing in its isolation. You know things only in comparison to other things. And as soon as you say that something has no dimensions, you're out of the empirical realm, and then anything goes.
Not really, Peter. Not really. If you imagine a quadrangle and you reduce one of the sides to nothing, a triangle is left. But your concept how to calculate the area of this triangle could be the same, following the same rules as if you would calculate, let's say, an irregular quadrangle. This is what the Egyptians did.
Yeah, no, I understand that, but what Jeff was saying is that Euclid defined a point as having no dimensions, and so
No, I didn't say that. A point. What he said. And I've talked with people who study Euclid in the Greek, and they tell me that in Heath's translation, a point is that which has no part. But what he meant by that, a point is that which cannot be partitioned into parts. That's how we should think of it. So that's how he defined a point. He never talks about dimension. He talks about magnitudes that are commensurable, but he doesn't really talk much about dimension. Of course, he understood 1, 2, and 3 dimensions, but he doesn't dwell on that.
So no, a point is that has no parts. Isn't that unity again?
It depends what you want to make of it. And some people have identified the point with unity. Some people have identified the point with zero. In history of mathematics, I'm not talking about current people. Simon Steven identified the point with zero. Other people before identified the point with unity. But basically based on analogy, it has no mathematical foundation.
So this discussion evolved out of my own suggestion to include
My
geometry.
apologies.
It'll be
We drifted away, but I couldn't resist.
No. It's a little premature now to include geometry, but I think we should down the line, simply because of the contrast value that it has. But let's not start with that. This I think would be difficult enough and quite a challenge.
Not in the first level, no.
if you are game, then let's, rather than me propose a whole set of problems, you please think of within your own mathematical background what might be an interesting situation that can be documented from your perspective from the times, and then let's see what kind of a set of problems we get and whether they can be compared or not, and whether it's worth an article or not. I would applaud it if it could be. I think it would be a contribution. It would be, to my knowledge, it hasn't been done before. Anything that hasn't been done before always appeals. Always try something new. Unless you see something else that could salvage the Zero project, because it looks to me now that this distinction between the placeholder and the numeral would probably be not indefensible. Do you agree with that, Avinash? Is there a distinction? Is there a distinction between the placeholder and the number 0 that's worth breaking our heads over?
No, nothing is worth breaking our heads over. But I mean, all one has to do is mention both the viewpoints and let the reader decide.
But what are the viewpoints? What is the distinction then? What did you say?
Well, I mean, the placeholder is just a convenience, whereas the number is a tool to do more.
But if you can operate perfectly well on that placeholder, as the Arabs did, well, as the Mesopotamians certainly did.
What about 1/0? That's a different animal, but that can be only discussed when 0 is a number.
The Chinese document that I read on this issue, it just simply states, dogmatically that one may not take 0 as a divisor.
Mm-hmm. That's what we do these days.
We don't know what the thinking went into that, but if that is the unique distinguishing factor between a placeholder and a number, it also seems to have occurred in every civilization. So it doesn't really get us anywhere.
I see.
Okay, Avinash, your game. Jim, you want to try it?
Okay.
All right.
Okay, I did this once before in my first published article on.
Oh, you did?
Yeah,
now
I did
you tell us.
Mesopotamia and Egypt. I did the same problem, which was the calculation of the volume of a cylinder in both cultures to show the difference.
Oh,
but that was a long time ago, and of course I could not do anything about India or.
No, but that's great if you already have a standard of reference.
But it's a geometrical problem of just a very, very sort of straightforward calculation of the volume of a given form.
Oh, that's fine.
If it was done by both cultures, I could use it as an example.
But if we don't know how they calculate it, then what are the intermediate steps that you could add?
There are the intermediate steps. It was precisely the algorithm for calculating the value.
Oh,
in the case I had the calculations. In the Babylonian case, I didn't.
Oh, you did.
But I mean, what was interesting to me was the procedure. Since we're in 0, that isn't the key point here, and so it isn't the best example of what one should choose for trying to somehow situate zeros.
No, but let's build from there. Let's start with Jim's comparison, which is ready made. Could you produce that for us?
Yeah, sure.
Yeah,
I can send you
that would be.
It was it was published in '89.
Do you have a copy? Can you send it?
Yeah.
Okay. Let's take that as a starting
That's good.
point. Yeah, let's take that as a starting point. What are the dates? Were they contemporaneous?
Yes, because the mathematics in the sort of breakup of mathematical history that Friedhelm was telling us is identical to what happens in Mesopotamia.
Okay.
So it's the Old Babylonian and the Middle Kingdom. in Egypt, and there are ones from the Rhine papyrus and the others from a
Which is what? Second millennium?
Which is the second millennium, first half of the second millennium.
First half of the second millennium.
In
That
both
means
cases.
closer to 1,000 than 2,000.
No, between 2,000 and
1,500
in Mesopotamia. End of the Middle Kingdom was when Friedhelm. Whatever.
And it's the first half of the second
First
millennium.
half of the second millennium.
First half of the second millennium. I'm confused whether that's the top half or the second.
Yes, exactly. Yeah.
The furthest from
Negative numbers. Negative numbers.
So he walks along the number line as 1,500 to 2,000 is the first half.
Is it from 1,500 to 2,000 or from 1,000 to 1,500?
It's from 2,000 to 1,500.
Oh, okay,
Yeah.
okay, counting back. Okay. All right. So they're contemporaneous. That the two problem thing that you solved. So it solves Friedhelm. You get off easy, Friedhelm, because Jim has done it for you. Of course, the Arabs.
Friedhelm might have some comments on what I did. So don't
So
And if
now
I
we're-
understood correctly, this is the starting point, and because this gives an idea which
Yeah.
problems could be
Yeah, but it's a
considered
geometry
later.
problem. It's a
Sorry?
Yeah, but
geometry problem.
that will be in the Vedic period too, right? In that period, we're talking about up to 1,500. Actually, we don't know, but up to 1,500, it was mostly geometric issues from which these things evolved. So there'll probably be a Vedic counterpart.
Go down to
That.
Shulba Sutras.
Yeah,
No, Mahabharata would be 1,200 BC, so it's very nice to look at that.
That,
yeah, but that's not
the example.
that's under debate.
I don't know if there's two-dimensional material in the Shulba Sutras.
sorry.
I said it's a three-dimensional problem.
Problem, yes, exactly.
And the Shulba Sutras, as I understand it, are altar areas.
Avinash, are there volumes?
Well, I mean, there are layers and there are rules about how the proportion goes for the bottom
Are
layer.
there volume?
And the middle
Are there
layer.
volume?
Yeah. No, I mean, they didn't, I don't know if they really called it a volume, but it's ultimately a three-dimensional figure. And the total number of bricks used had something to do with the person authorizing the
Are there any calculations that you could lay your hands on?
Yeah, I mean, I have to look up.
It's possible.
It's
Okay.
the Shulba Sutras which have these calculations first, I mean, as far as I know.
Okay, so that leaves out the Arabic at this moment,
Yeah.
right? Where were we? 1,500 BC, Jeff?
We were just herding animals and
So what about calculations of granaries in Arabic countries?
oh, okay. I was speaking 1500 BC.
I understand, but I mean,
Yeah.
But on the other hand, the ways that were used to calculate
Yeah.
the areas, say, of a cylinder.
Yeah. Oh, yeah. They had. There are a number of texts in mensuration which do survive. Al-Khwarizmi's algebra book is the earliest one, which has a chapter on mensuration in it, which is basically unrelated to algebra. And they had basically practical techniques for calculating areas and volumes, which anybody who was a surveyor or an architect would need to know.
Mhm.
But Al-Khwarizmi dates it back to a very early period?
Well, the 9th century.
No. We're talking about the
BC.
There's nothing in I don't know how you even call it. It's not Islamic. Then if we're talking about 1500 BCE, but the Middle East is south of Mesopotamia. Is I don't know if we have any. Do we have any written materials?
Well, there are Persepolis, etc., 600 BC, the Persian thing.
I don't know.
Darius the Great, etc., are there. So the kingdom was active at that time. You have this famous city of Persepolis, 600 BC. So they would have been active at that time.
600 is not 1500, and 1500 is
No, but 600 is the climax. So my guess is that the Gaussian would have gone.
But is there any written material? Anyway, anybody, not anybody here who can reproduce it instantly. So, Jeff, I'm afraid you don't come in until a little bit later.
Jeff, I would like to see an Arabic calculation of volume.
Yes, definitely.
If you have.
Well, actually, all you have to do is look at the translation of Al-Khwarizmi's book. Rashid published a French translation, which was also translated in English. And although I have problems with his interpretation, his translation is quite literal. So if you just look at the second part of Al-Khwarizmi's book on mensuration, you'll find it there in English.
Is it verbal or is it also calculation?
Well, it's all verbal. I mean,
it's all verbal.
The whole book is verbal. There's not one symbol for anything in the whole book.
Would that help you, Jim? If it's verbal?
Well, I mean, it would help. I mean, in the sense that there isn't anything calculational in the Mesopotamian case either. It's a series of instructions of our
okay. It's also verbal.
Well, verbal. I mean,
but there are no calculations.
Right.
The numbers are written in words in the Arabic texts. They write the numbers in words, so the numbers are there.
The numbers are written in words because they're not words in the Mesopotamian case. But that's the only symbolism that there is are the actual representations of numbers as such.
Yes, this is the same in Egypt. But we have also little sketches for geometrical problems.
And we have some as well.
So would that be word numerals, what we call word numerals?
Yeah, if you like, you write 45, FORTY-FIVE. That's
Why not?
Yeah, but is that the same in Mesopotamia? Are they word numerals like that?
No. They're symbolic. I showed you them on my talk.
There's a cultural reason they wrote those words in Arabic. There's a cultural reason. The books were regarded as transcriptions of lectures, and symbols don't do anything for the listener.
Right.
So they're written words.
Yeah, but the question is a practical one. Can we manage with the material that we have to even represent the problem? Jim's comparison, if it's a verbal one, can you do any actual? I mean, even theoretically, I mean, in reconstructing, can we reconstruct the possible way of that these people may have calculated the results?
Well, in the case of Egypt, it's explicit. In the case of Mesopotamia, it's not. I mean, there's multiply 37 by 42 is one step.
Okay.
And then the answer of that is given in the Mesopotamian case, and in the Egyptian case, it will be given, but it might also be shown as a calculation of the kind that Friedhelm was telling us.
Okay. So you can manage. All right. Well, then again, we there's a big time gap there between them. So we should maybe then think of an intermediate problem. And let's start with this, and then meanwhile think what the next logical step would be in jumping from that example, Jim's example that we might try to match in the Vedic period and the Egyptian period.
Peter, can you send a common email to everybody so that we have all the email addresses at one place and you do reply all and keep discussing?
Yeah, you already have that. That's why you're here.
No, but that has other names and addresses also in it. I was just checking that.
Yeah. Oh, okay, but that is something that we have to include the other people as well.
Okay.
In case they can jump.
That's fine then. I have no problem.
I'll do that. Yeah, I'll definitely do that. I've already been doing that.
Because I couldn't find Avinash Satte's email.
He just joined. He was graciously accepted our invitation very last minute because I knew him to be conversant with both the modern mathematics and ancient Indian mathematics. And in fact, that is part of the issue that we're facing, is that if it is an anachronism, then it is something we're imposing from our modern mindset onto the ancients, which would not be fair, as Jim says, is already being recognized widely. But that's why Avinash is here. If he would care to stay, it would be wonderful. Stay in the group until we, see where it leads. Celestine and Alexis might join in at a later stage. Marina was a little overloaded today, so she couldn't join, but she may have some pertinent things to say, and that'll make an interesting combination of expertise to see whether we can take it forward. It's not, you know, it's not a foregone conclusion that it will happen, but let's give it a try.